So my main interest is in using stylometry for forensics. So what happens when we don't have a candidate author, but rather we receive a manifesto and we need to profile it quickly. In this case, I'll be focusing on profiling profession. Disclaimer, I messed up in the abstract because I miscounted and I had to redesign the corpus, but my results are still significant. It's just, for the sake of honesty, do not rely on the abstract. So stylometry is usually used for authorship attribution. It essentially takes statistics and key features of a person's writing style and quantifies them statistically in order to measure the distances between different authors and a disputed text. It has forensic applications, as I will show. But again, what if we have no suspects, only a manifesto? Then we need to profile that. Stylometry can profile many things that have been shown, like gender, Myers-Briggs personality type, and now profession, among other things. As you can see, age, to native language, nationality, regional affiliation. There's many profiling uses for stylometry. So the Unabomber is an ideal test case because he was a lone terrorist who did all of his own writings, meaning the document is not co-authored as far as we know, and has a verifiable association with academic mathematics. Namely, he wrote in the field of complex analysis. So is the Unabomber Manifesto stylistically similar to academic mathematical writing as opposed to the writing of any other profession? The research question is, does academic training, and specifically academic profession, leave detectable traces on the author's writing style? So the corpus consists of 120 papers in mathematics and mathematical physics by 12 authors, 60 verbose and 60 non-verbose. Essentially, it depends on how many mathematical symbols an author is using, because that leaves holes in the text, right? We have to clean them up. And that means that, for example, analysis of POS tags or parts of speech tags will not be as accurate because of these holes, right? A mathematical expression is a part of speech. It has its sense, but we cannot easily translate it into natural language. So 60 on economics, grouped by journal, 60 in continental philosophy, all of them are grouped by journal. So what we have are a lot of authors, but in order to minimize the impact that any particular author may have had that was closer to Kaczynski for any reason, we group them by journal so as to have, for example, in one document, 10 papers on complex analysis by 10 different authors, 10 papers on real analysis by 10 different authors, and so on. Also, to balance those holes, I added NSF, which is the United States National Science Fund. Those reports written by mathematicians, medical scientists, economists, and philosophers. That being said, you will see some surprising results about these because these are written by mathematicians, by economists, and so on. But obviously they have a different language. So as I said, each file contains between 15,000 and 50,000 words. And the main difference is how heavily symbolic the original papers were. So in the ones with 50,000 words, they have a lot of holes because they're composed of heavily symbolic mathematical papers. So I gathered my corpus between 1960 and 2010 to account for the time that Kaczynski was active both as a mathematician and a terrorist. I used 3 different software models. The first one is JGAP, developed by Patrick Yola. It provides different analysis methods. I used 68 across different analysis methods and features, but I had to discard several of them due to unreliability. I trained the models on the papers, and I asked, is Kaczynski classified as a mathematician, both above chance, which, since we only have 4 professions, is 25%, and more than the incorrect profiling of Kaczynski as some other profession. I also used Langsbox, which is developed by Lancaster University. You may have heard of Batsua Brezina. And that gives us very good visualization of, for example, collocations. And finally, Stylo for clustering analysis and PCA to provide yet another visual component to my analyses. So as you can notice here, the largest feature space is only the 50 most frequent words and 50 most frequent word stems. Clearly, these are sparse spaces, but it's important for them to be sparse because we were only aiming to, well, I was only aiming to capture function words and not content words. Essentially because the content words of each profession do not show in non-professional writings, like in writings outside of the profession. So I focused on the distribution of function words. In cross-validation, the accuracy was pretty good. Health sciences was the lowest one. Not clear why, but I couldn't just discard it. Honestly, it passed with over 70%, almost 75%. So I figured that was acceptable. Now, it's important to see that the main misattributions were between economics and math, because both of them, I have non-verbose and verbose economics papers as well, meaning heavily mathematical papers in economics. I actually chose economics on purpose in order to have that similarity and heavy mathematical symbolism to see if we could still tell the professions apart. And it turns out that 94.5 and 85.7, well above chance, we can. Now, chance in this case is 25%. Again, I only had time to gather many, many papers by only 4 professions. But as you'll see later, I plan on doing more studies with more professions. So inaccurate methods. They produce ties for first place, or they fail to pass cross-validation, such as Mahalanobis distance. The centroid drivers and perceptrons often had ties for the first place. But in general, centroid and k-nearest neighbor methods were pretty inconsistent with profiling professions. And I will develop that inconsistency in a little bit. So only a few methods passed cross-validation with punctuation pentagrams. A pentagram or an n-gram is essentially, instead of taking the 50 most frequent words as individual features, each word, an n-gram is taking, for example, a 2-gram would be taking 2 words, or mapping collocations. A 5-gram would be taking 5 words, then 5 other words, then 5 other words, and so on. So the algorithms that pass cross-validation, sorry, how are we doing with time? Okay, I'll go into the technical detail. I didn't know if I should go into technical details or not. So Burroughs delta measures the distance between a text of unknown authorship and a corpus with several different authors by comparing how each text in the test set diverges from all of them put together. I used linear discriminant analysis, which essentially when you have documents that form clusters and are separated by distance, you make a sort of regression line in order to see if they are separable into 2 different categories. I used a Markov chain analysis. I used think cross entropy, which calculates the distance between 2 events which are not necessarily independent. Cross entropy is the measure of unpredictability of a word in this case, given a model of words and their probabilities. Least median squared is essentially regression, but instead of doing the sums of squares, we take the median of the squared residuals. I used normal linear regression. I used sequential minimal optimization, which essentially does pairwise classification in order to break down a large feature space into individual features in comparison and then kind of letting them all vote. And then I used a voted perceptron, which builds multiple neural networks or perceptrons. It's usually the simplest kind of single layer neural network, but one on top of another, building on the errors or the error margins of the previous neural networks. So the more you kind of boost and the more you add, the less margin of error and misclassifications you'll have. So these are the results with JGAP. As you can see, the voted perceptron is it did really good. So did least median squared. This was expected, but honestly, it's suspiciously good that they did it well across all features. I personally find that very suspicious. Now, reliable methods do not only perform above chance, so above 25%, and significantly so statistically, as the 50 most frequent words had 87.5% accuracy, but they do not misclassify consistently. So, for example, here we see that with word length, it's equiprobable that it's philosophy or mathematics. So the ones represent mathematics, and the words represent misattributions. The important part is that across the methods, even with relatively low accuracy like 60%, there wasn't consistent misattributions. So there's a very low percentage of consistency across which other professions were misattributed. So as you can see, again, the most reliable method is the 50 most frequent words, which are, again, all function words, not really any content words, the 50 most frequent collocations, and character n-grams were very reliable, as were the 50 most frequent stems. So instead of just 50 most frequent words, I took a lemmatizer to them, and I measured the 50 most frequent lemmas. So as you can see, there's several other methods, like linear regression across features is unreliable. But still, it is a good method that passed cross-validation with all the features. So the results on Stylo, just note this. MD is medical sciences, E is economy, P is philosophy, and then I divided math into 3 subcorpora to be clear on how verboseness impacts closeness to the terrorist manifesto. And as you can see, the Unabomber's terrorist manifesto is actually, MA, is the least verbose of all of them. So it turns out that the holes did not matter. What also did not matter, actually, is whether or not complex analysis was included in the sample. This means that Kaczynski was significantly closer to mathematics, regardless of the topic. Even though he himself wrote in complex analysis, he is not closest to complex analysis. He's actually closer to, I think, abstract algebra, if I remember correctly. Actually, complex analysis is MA4, so for the 20 most frequent character tetragrams, as you can see, he is much closer to these two in math, and significantly so. Thank you. Going back for a second, notice the cluster form here with the 15 most frequent collocations. This is in almost 82% of the variance is captured by these two principal components. So with 82% certainty, we can say that Kaczynski can be classified as a mathematician. And here it's with about 54%. So the results on Langbox, if I did not mark it or highlight it, Kaczynski is closer to another profession. If I highlighted it, it's closer to math for that particular collocation or feature. And if it's a blue line, there's not a significant difference in distance between math and another topic. So as you can see, especially on the top 10, of the most frequent collocations, even though they're function words and not content words, significantly above chance we get that Kaczynski is classified as a mathematician. Likewise with part of speech pentagrams, which in JGAP did not do so well, did much better in Langbox, where we can look at individual features, and essentially if you right-click on any of these, it will show you a list of frequencies, such that you can figure out, oh, this one is closer in frequency to mathematics, and so on. So even though this is a corpus linguistics method, we used it for stylometry. So coming to an end, academic profession profiling may be feasible at a large scale, but I need to account for non-academics and to understand the low accuracy. So I believe, and I checked, that I cleaned the corpus well. But it has holes, right? So that could be the problem. Small corpus, not in the sense of professions, because I had 60 papers by each, but rather in the sense of, well, I only had 4 professions. But we still, and I need to stress this, dealt significantly above chance results. Therefore, Kaczynski can be classified as a mathematician as opposed to any other professions. So for future work, I will redo the experiment with a bigger corpus with at least 10 professions and non-academic professions. And I will do more case studies. For example, Jacques Bossoon was a historian who also wrote books on how to write academically. Von Neumann famously wrote Can We Survive the Future? And Bertrand Russell wrote, apart from being a philosopher, Nightmares of Eminent Persons and Other Stories. Thank you very much. I hope you enjoyed this, and I'm sorry for the mistakes I made.